Hi, I thought today, as it's a Sunday and a bit of a lazy day, well, I'll say lazy day, I've actually been doing a fair bit of modification work on my 3D printer. Anyway, thought I'd do a little kit build. I've had this sitting around for absolutely ages. If my throat sounds bad, I do apologise. I've got rather a nasty chest infection at the moment, so just getting over that. So this kit build came from BangGood. It's a arc lighter, runs on 3 to 5, between sort of 3 volts, 5 volts. Says use up to 3 amps, so we'll have a look at that. And these, I don't know what price I paid at the time, these you can pick up now for around £2. It's currently listed at £2.9p from BangGood. If you're interested in getting one of these. So let's pop it out and see what we get, and that pretty much is not a lot, as you will see. So, one PCB, one button, got a diode, cable tie, and a screw. How exciting. We've got a transistor here. This is a Fairchild, it's the D880. It's got the -1 as well, so that's a NPN transistor. Cheapy capacitor here. What have we got? 470 microfarads, 16 volts. Connector blocks there. We got a resistor here. This is a 32 ohm, sort of one of those high power ceramic style resistors, so that's probably going to get quite hot, I'm sure. And here we've got a little transformer. So these leads here will be the actual ones that you create the arc between, and then these ones need to go onto the actual PCB. You don't get any instructions with it at all. I'm hoping the transformer's relatively simple to work out. I think probably just look at some pictures and see if that explains. I'm imagining it would go like that, something like that. So then the wiring should match up with the wires, the traces on the PCB. Obviously it'd be unlikely you'd have it that way round, because then you're ending up with quite a big gap there, as you can probably see. So I think probably it goes flat like that. So we'll have a look at that. Right, the soldering irons are all on and heated up and ready to go. So I think what we'll do is we'll go for the diode and resistor first. So it's a diode here. See on it? It's a D. No, sorry, where are we? Oh, IN4. It's an IN4007. That diode there. So let's just pop this one in here. Now, sorry if this is all going to start going out of focus. I really need to actually spend some time with this camera and actually get things correct on it. Right. Right, that one's popped in the right way. So just solder on that. Certainly a very good starter kit, this one. Minus the high voltage side of it, obviously, but certainly good from the point of view of really easy kit to build. I mean, there's nothing to it. There's very few components on this. So let's just get the clean that a little bit better. Might help. That's that side. Good, flow through nicely on the other side there. Put those leads. Oh, that one's gone somewhere. Right, next one, let's do this resistor. It's always best to do components in a size, makes it a lot easier when it comes to soldering on the board. Any specific way I want this? Not really. Let's have it that way. I do. Pop that down there, and let's pop some solder on that there. That's gone through nicely. I might just pop a little bit more on this side. It's not quite flowed through to the other side of the board. Needs a little bit more time and heat due to being a power resistor, so it's designed to take away the heat. Still not quite right, but that's fine. Actually, I'll tell you what. Just crop those leads. Yeah, so one pain I have with this camera is the autofocus just doesn't seem to be quick enough to me. Sometimes I feel that it's actually more the actual display. It's hard to tell. Sometimes you shoot stuff and you're sort of looking at the on-screen display and you think, well, it's not really. It's hunting for focus. It's not getting it quite quick enough. And then if you actually watch it on the playback on the computer, sometimes it's not actually that bad. Right, let's go for this switch or transistor. Yeah, let's get this transistor in first. Now this one's designed to screw down on the back of the board and have some heatsink compound on it as well. So I think they don't actually supply you with any thermal compound. Well, I have got some lying around. Just trying to work out the rough position to get these legs bent in, so we can get that screw in there. Right, that's not too bad like that. Is that gonna? How are they gonna put that in there? It's not got. Yeah, there. A little nut for the other side might be quite useful. Sorry, I'll come out there. Yeah, this screw. Yeah, you can see my slight problem there. One screw. That's back out again. They haven't supplied a nut for that. Right, let me just go and get some thermal compound, and I'll go and find a nut for the other side of that screw, and then we'll carry on. Okay, I managed to find a little nut there. So let's pop this back out a little bit. It's probably not really vital that this has any compound on the back of it, but I think just stick a little bit on just to be on the safe side. That'll do. A little blob in the back there. Okay, put that down. Yep, all oozed out everywhere. Okay, just see if we can pop this little screw through. I don't know if I managed to lose the actual nut, or if they just didn't send one. I don't remember ever seeing one, so I think the chances are that there was never one with the kit in the first place. Let's see, screwdriver. I'm not going to do it up super tight, just going to clamp it a little bit and just give it a little tweak. That'll do. Right, a mess there. Let me just clean that up. Okay. Get that a little clean, just so I don't get that all over the place. So yeah, it's very unlikely it's really needed. It's probably why they don't supply any thermal compound with the actual kit itself, but we shall find out. See how hot it gets when we get it built, if it works, that is. Right, so that one's screwed down, so now we can get that one soldered as well. So, being an arc lighter kit, if you don't know what that means, what it's going to do is basically create a high voltage arc, so a kind of spark, and you can use it as a lighter. Obviously if you're a smoker, just a novel item really. You could use it for burning a bit of paper or something. Maybe even light a candle actually, that's a good point, might work on candles. Alright, let's just trim those off. Okay, right, switch I think we'll do next, because that one goes up here. And that's going to go that way by the looks of it. Good thing about these is they hold themselves in nicely as well. So just pop it in like that, and then ready to solder. Nice and simple. Obviously they're not using all the pins on it, but I will just solder them in anyway. Just helps hold the switch in. Okay. Right, so now we've got the capacitor and the transformer and the input connector block there. So let's do the capacitor now. So this one is polarity sensitive, so you can see here it's got plus mark there as well, and you've got the dash, and dash is always negative, so negative side of the capacitor. So we'll pop that in like so. I'm just going to push that forward a bit so it sits roughly within the footprint that's been provided there. What I want to try and do, if this works out alright as a kit, I think I'll 3D print a little case for it, and it's about a good size for a 18650 lithium cell, because it works between 3 and 5 volts, so that would be an ideal voltage as well. So might be able to actually make it into something that's could be usable, as opposed to just a sort of PCB kit that could pose a bit of a danger, obviously, with the high voltage. So that's the plan. Yep, I really should put my hand over while I do that, forever cleaning up little bits of metal everywhere. Okay, that's capacitors on. So this one goes over here, and then we just got to pop the transformer in. That one I'm going to have to look at a picture on BangGood and just see roughly which way it looks like they've actually got it round. Might not matter actually. Not quite sure what how the windings are laid out on that transformer. But yeah, it may not matter which way round it does go, but logic would say the way we was looking at the first time, that's probably going to be the way it goes. You want it to sit nicely on the board and look nice and neat. Let's just have a look at this website. Yeah, that doesn't really show it very well. They're using a different transformer on the picture. Like I say, this one I brought a while back, so chances are it's they've obviously changed it quite a lot. So looks like these two obviously need to stick out. So I think I'm just going to go for it as that being that way around. So we're going to do this thing because they've tinned the end of the wire, but I don't really want. Yeah, I'm just going to push them right through. But can I get that one there to go right through? I've got the one in the middle has been twisted together. It's a 2 that's twisted together, so I'm going to try and get that one, both of them through the same hole, which could be. Oh no, it's going in. Yeah, so although they've tinned the ends of the enamel wire, this would be solderable enamel wire, I'd imagine, so it shouldn't be too much of an issue. Just to heat it up and melt the enamel off. So let's have a look. Okay. Yeah, so that wants to sort of sit something like that by the looks of it. So we will pop that cable tie down while we're at it to keep that nice and secure. Let's see. Let's stop it moving around while we're trying to get the solder on as well. Yeah, his chest infection is a kind of nasty one, and a bit of an unusual case because I didn't actually just I went to the doctor's a couple of days back with the complaint of a bad neck, which I had for a couple of weeks. Well, I probably just slept funny, and a rather really painful headache. And apart from that, I had a bit of a cough. That was it really. And yeah, drove up to the doctor's, saw the doctor, she did a food test, and called the ambulance. It was like, you need an emergency ambulance down to hospital. So yeah, it turned out a bad case of pneumonia and septicemia at the same time. So I've spent the last few days in the pleasure of the hospital, the wonderful food. Not. So yes, it is nice to be back home, but yes, not going to be 100% for a while. Right, so I've got that transformer clamped down there with a cable tie. As I say, it should be solderable wire, so this should just burn the enamel off with the heat and the solder. It shouldn't be too much of an issue. I say that. Have they gone and used non-solderable wire? Or is it? No, it is. I think it's taking. Yeah. Let's whack the heat up. I think up to 450 on the iron for this one, because I'm not sure that's taking correct. And you do technically need to use a really high heat, ideally about 400 or so, to burn the enamel off anyway. I've actually got a solder bath here. It probably would have been a better idea to have that on and burn the enamel off before I put it in, but we shall persevere. Right, let's try again. That's better. I just don't want to lift the track so I can avoid it. Right, that's a right mess. Let's just inspect that off camera. Right, I've had a look at that. I have cleaned it up a little bit with some IPA. Yeah, it's not great, not particularly happy with that. As long as it's making a connection, that's okay. I did have a little go at it on the back side, burnt the board there as well, but not to worry. Yeah, I think probably because I got a solder bath, what I should have done really is heated that up first. Use that to burn all the enamel off. If you haven't got a solder bath, you can use your iron, put your iron up to a high temperature and just run it along the enamel, and that should burn it off. And then once you got it burnt off where you need it, then put it in. That'll probably be the easier option. Right, so these bits apparently just stick up somewhere. So now we just need to give it between 3 volts and 5 volts. Okay, let's grab some wires, connect it up and see if anything happens. Okay, I've got the power supply hooked up. I've just got it set at 3 volts at the minute, so what we're going to have to do is bring these pretty closer together. I don't know how close they've got to be. Try that and press the button. Aha! See that? Oh. Yeah, got an arc there. So it's got to be quite close together. So it is drawing, that's 1.3 amps running that arc there. Let's increase the voltage. It's got to 4 volts. Oh, you can hear that now. And that's drawing 1.6 amps. We should be able to draw a slightly wider arc. Let's have a go at that. Yep. I don't know how high the voltage is on this. Can't quite jump that. Let's try 5 volts on that. No. Oh, just... yeah, so it was a bit too big of a gap. So that's drawing 2.1 amps. Okay, so lights out. There's your arc. 2.1 amps. You smell the ozone off that. That's pretty neat. Tell you what, that transistor is getting pretty hot. Got a fluttery one there. How have we done that? Or is it just God, I tell you what, everything's getting hot. That capacitor's pretty hot. No, sorry, me. Finger in the wrong place. Too far apart. That's a neat little kit actually. So yeah, certainly running it at 5 volts seems sensible. So yeah, it's 5 volts, it's drawing 2 amps. So what we want to look at is if we're going to run that on a LiPo, so nominal voltage of 3.7. Yeah, we still get a nice arc off that. Depending on the spacing. But obviously you'd be looking, I mean I was saying nominal voltage of 3.7, but you've got fully charged of 4.2, so we say 4 volts. And yeah, that's fair enough. Seems alright. Right, can we burn anything with it? That's the question. Where's that Q-tip gone? That's got some IPA left on it still. See if that will. Yeah. Yeah, that worked. Had some IPA on it. So yeah, a bit of paper or anything like that shouldn't be a problem at all. I'll say that. Must have a bit of scrap paper somewhere. Scrap paper here. Just run that between the arc. Yeah, easily set fire to that. So yeah, it certainly works as described. So there you go, guys. Smoke effects and all. Let me try not to set fire to the place. So there we are, that is a arc lighter off BangGood. Yes, you can pick them up for a couple of quid, cheap as chips, and as in the case of this one, works quite well. Nice little kit. Again, it is high voltage. I don't know quite how high the voltage is, so I can't sort of say if it's super safe or not for kids to be building unsupervised, but supervised is not a problem. And really simple kit. If you like this kind of video, please give it a big thumbs up. That really does help, guys. Please subscribe if you haven't already subscribed. And funding for these videos, I don't just have a magic money pot, so If you guys do like these sort of things and you want to help out, links are down below to Patreon. Please consider subscribing to me on Patreon, so I can hopefully buy some more stuff like this and carry on with these great videos. Thank you for watching, guys, and see you soon. Cheers.